All right, our next unit here is factors and products. The interesting about this one is it actually goes over two different sections in the textbook. We're going to start with chapter 3, 3.1 and 3.2, and then we're going to jump to chapter 4. And this will make sense why if you look back at the outcomes that we're dealing with and how it just kind of works with the curriculum. So 3.1 is factors and multiples of whole numbers. When a factor of a number has exactly two divisors, one in itself, the factor is a prime factor. So when we look at 7, it is just 1 and 7. Here are our first 10 prime numbers. These are worth memorizing, or at least having a solid knowledge of what they are, because we're going to be dealing a lot with prime factorization. So we're going to start by writing 12 as a product of its prime factors. So the first thing when I think of dividing into 12, I think of 2, and I think of 6. But 6 is not prime. 6 can still be broken down into 2 and to 3. At this point, all of these numbers are prime. I do not need to factor anymore. If I want to write this as prime factorization, this is 12 is equal to 2 squared multiplied by 3 to the power of 1. Now that 1 is and isn't important. It helps you kind of as a placeholder to remember that it's not 0. And it does come in useful when we're looking at greatest common factors and least common multiples. So let's do the prime factorization of 3,300. You can use any set of divisors as long as it divides in cleanly. So for instance, 5 would work, 2 would work, 10 would work, anything, as long as it divides in cleanly. Like, I don't think 4 works. When I look at this, the first thing I think of doing is 100 multiplied by 33. Because I know 100 breaks down into 10, into 10, into 5, and into 2. This is prime. Now I'm going to go over here and I'm going to deal with 33. 33 breaks down to 3 and into 11. So that's good. Now this comes down all onto one line to let us know that this is the whole multiplication statement to get to 3,300. If we write this as prime factorization, always go in ascending numerical order. So start with the least, which is our 2 squared, multiplied by 3 to the power of 1, multiplied by 5 squared, multiplied by 11 to the power of 1. Okay? Now we will go on to determining the greatest common factor. We have 3 steps here. Write out the prime factorization of each number. Highlight the factors that appear in both prime factorizations or all prime factorizations. Then simplify the factors that you've highlighted. Simplify meaning multiply the factors that you've highlighted, or circled, or boxed, whatever you do. So let's look at 138. What goes into 138? For sure 2, because it ends in a multiple of 2. Multiplied by 69. 69 breaks down to 3 and 23. If we remember our list from the last slide, 23 is a prime number. So then 138 is equal to 2 to the 1 multiplied by 3 to the 1 multiplied by 23 to the 1. 198 breaks down into 2 multiplied by 99. 99 breaks down to 33 multiplied by 3, and 33 breaks down to 3 multiplied by 11. Okay, so then we write this out. 198 is equal to 2 multiplied by 3 multiplied by 3 multiplied by 11. So then we can see here that we have 1 set, 2 set. So then I'm going to state this as the GCF is equal to 2 multiplied by 3, which gives us 6. So the biggest number that's going to divide cleanly into 138 and into 198 should be 6. Let's try it with this next one. Determine the greatest common factor of 126 and 144. Pause the video here, give yourself a chance to try it, or follow along if you need to, but the answer will be here when you come back. So 126 factors down into 3 multiplied by 42, 6 and 7, 3 and 2. So then this changes to 126 is equal to 2 to the 1 multiplied by 3 to the 2 multiplied by 7 to the 1. 144 breaks down, first thing I think of is 12 multiplied by 12. And then this breaks down into 4 multiplied by 3, 4 multiplied by 3, 2 multiplied by 2 multiplied by 3, multiplied by 2 multiplied by 2 multiplied by 3. And then we write it out. And we get 2 to the 4 multiplied by 3 to the 2. So we only have one copy here. So there should only be one copy here. And we have 2 here, so we can circle both of these. So my GCF will be 2 multiplied by 3 multiplied by 3. So that gives me 2 multiplied by 9, which gives me 18. So the biggest number that'll divide cleanly into both of these should be 18. Now let's look at the least common multiple. A least common multiple, if we remember correctly, is the smallest number that they will multiply to get to the same value. So if we're looking at 18, 20, and 30, it's like if we count it out, we'd go 18, 36, 54, and we'd keep going until we counted it out, which was really easy when we were dealing with numbers like 2, 4, and 6. Like you should know that the LCM of this equals 12 just by looking. So when we do this now in grade 10, we're going to write the prime factorization of each number. And we're going to highlight the greatest power of each prime factor in any list. Then we will simplify, meaning multiply the powers we have highlighted. So 18 breaks down into 2 multiplied by 9 multiplied by 3 multiplied by 3. 20 breaks down into 4 multiplied by 5. 4 breaks down to 2 multiplied by 2 multiplied by 5. 30 breaks down into 6 multiplied by 5, which breaks down into 2 multiplied by 3 multiplied by 5. So if we write this out, 18 is equal to 2 to the power of 1 multiplied by 3 squared. 20 is equal to 2 squared multiplied by 5 to the power of 1. And 30 is equal to 2 to the power of 1 multiplied by 3 to the power of 1 multiplied by 5 to the power of 1. So we are looking for the greatest power of each prime in any list. So the greatest power of 2 is 2 squared. The greatest power of 3 is 3 squared. And the greatest power of 5 is 5 to the 1. Now, it didn't matter which one of these, but you only need one. So the least common multiple is equal to 2 squared multiplied by 3 squared multiplied by 5 to the power of 1, which means that this is 4 multiplied by 9 multiplied by 5, which should give us 180. So if we wrote it out in a list and counted it up, the first number that would appear in a list of us going up by the value, so 20, 40, 60, 80, 100, 120, 140, 160, 180, 30, 60, 90, 120, 150, 180, and then you count up 18, and then 180 would be the first one that appeared in the list. Pause the video here, give this one a chance for yourself, come back, check the answer. So 28 breaks down into 4 multiplied by 7, 2 multiplied by 2 multiplied by 7, 42 breaks down into 6 multiplied by 7, which breaks down into 2 multiplied by 3 multiplied by 7, and 63 breaks down into 3 and 21, and 3 and 7 and 3. So then we write this out. 28 is equal to 2 squared multiplied by 7 to the power of 1. 42 is equal to 2 to the 1 multiplied by 3 to the 1 multiplied by 7 to the 1. And 63 is equal to 3 squared multiplied by 7 to the 1. Our highest power of 2 is 2 squared. Our highest power of 3 is 3 squared. And our highest power of 7 is 7 to the 1. So our least common multiple is equal to 2 squared multiplied by 3 squared multiplied by 7 to the 1, which gives us 4 multiplied by 9 multiplied by 7, which should give us 252. All right, so your assignments at the bottom here. Whenever I say odd values, I'm talking about ACE, not B and D, because this should be 1, 3, 5. But it just gives you a chance that you don't have to do all the questions right now, but instead that if you want to go back and practice, you at least have other questions to practice. If you have any questions or notice if I made any mistakes in the video, please let me know. Answer me in the Google chat if you have any questions. Good luck.